Arushi is saving money from her part-time job. She deposits $200 at the end of every month. So she's putting in money at the end of every month into a savings account which pays 6% per annum, compounded monthly. Arushi would like to know what her savings would be in 1 year. So because she is making regular payments at regular intervals, so she's making regular payments of $200 every single month, this is an example of an annuity. She's not just making one payment and leaving it in an account. That would be compound interest. Instead, what she's doing is she's making a regular payment over regular intervals. So every month, she's making a $200 payment. That's what makes this example an annuity example. Okay? And so, what you want to think about is, she wants to know how much money she's going to have at the end of 1 year. Now, if you think about it, if she puts money into an account, at the end of the first month, that $200 that she puts in will be in the account for an additional 11 months, so that until the year actually ends. So let's say she puts money in January. At the end of January, she puts in $200. That investment that she puts into her account, that's going to stay there until the end of December. So that's going to stay there for 11 months. So what that means is that $200 that she puts into the account at the end of January will gain interest for 11 months until the end of December. Okay? So then at the end of February, when she puts in another $200, what will happen is that amount of money that she puts in will stay in the account till the end of December. So that $200 is also going to earn interest, the $200 that she puts in at the end of February. And so that $200 that she puts into the account will only get interest for the next 10 months. So from the end of February till the end of December ends up being 10 months. Okay? So she's already earning money from she's already earning interest from the $200 she put in at the end of January. Now she's going to earn some more interest on the $200 she puts in at the end of February. Same goes for March. March is going to stay in the account for another 9 months. April, the $200 she puts in will stay in the account for 8 months, etc., etc., etc. So that trend is going to continue. And so the total of all the investments that she puts from the end of January till the end of December will help us figure out what her total accumulated amount will be at the end of 1 year. Okay? So remember that Arushi will be earning interest monthly. So to find the total investment at the end of 1 year, we can add the accumulated amount of each deposit at the end of 12 months. So we can look at the accumulated amount of her of the $200 she puts in at the end of January, then at the end of February, then the end of March, etc., etc., all the way till the end of December. Okay? So first what we need to do is think about an equation for the accumulated amount at the end of each month. Now, this is actually looking at compound interest. And so using compound interest, we'll come up with the annuity formula. So what we're doing here is using the compound interest formula to figure out how much her accumulated amount would be for the investment she puts at the end of January. And then we'll do the same thing for the investment she puts in for the end of February, and then March, April, May, June, etc., all the way till the end of December. So here's our compound interest formula. Here's the principal amount, which is $200. So let's say she puts in $200. The interest rate per compounding period, well, she's earning 6% interest per annum. But the interest is compounded monthly, so we need to divide that by 12. And so our interest rate ends up being 0.005. And N is a number of months, and we'll talk about that because it depends on whether she puts the money in January, February, etc., etc. So here's our summarized equation. And now let's see what happens at the end of every month for the 12 months. Okay, so her accumulated amounts at the end of each month, starting with the first month. So let's say this is January. The $200 she puts into the account stays in the account for 11 months. So that's until the end of December. So this is her investment at the end of January, let's say. Okay? Then she puts in another $200 at the end of the second month. So let's say the second month is the end of February. Well, if she puts in money at the end of February, then by the end of December, that's 10 more months. So this $200 investment that she puts in stays in the account for 10 months. And so this is the investment she made at the end of February, let's say. Okay, at the end of the third month, or let's say at the end of March, the money that she puts in, the $200 that she puts in, stays in the account for 9 months. So it earns interest for only 9 months. So if that trend continues, and we move on to the 10th month, so now this would be the end of October, then that $200 investment will only stay in the account for 2 months. The end of November, then the end of December. So that's only 2 months. Then she can put in $200 at the end of November. That money is only going to earn interest for 1 month. And then she'll put in money at the end of December, and so that'll only be there at the end of December. So that one's actually not getting any interest. So these are all the different investments that she makes from the beginning of the year to the end of the year. Now the sum of all these accumulated amounts, sum being the key word here, if the sum of all these accumulated amounts will tell you her total investment amount at the end of that 1 year. So it'll tell you how much money she'll have in her account at the end of 1 year. Okay? So remember, she's only actually put in $200 at the end of every month. And so you would think that maybe she would only have 200 times 12 months, so maybe $2,400. But remember that each of these payments that she made has actually earned interest. Now, if we actually look at the total investment, well, we can add all these values together to actually find the sum of the total investment that she has. So that's from December, November, October, etc. till February and January. So those are all the investments that she made. So if you actually notice what happens here, this actually forms a geometric series. This is the same geometric series that we saw in the second question of the warm-up, where the common ratio is 1.005, the first term is 200, and the sum, well, the sum we know we can figure out in a few minutes. Okay? So, how are all these numbers related to the actual problem that we were looking at? Well, this 1.005 comes from 1 plus the interest rate per compounding period. So this is actually 1 plus I. So what this part here in the equation represents is 1 plus I. That's where that actually came from. Okay, where does this 200 come from? This 200 is how much she's actually paying on a monthly payment, on a monthly basis to actually invest in her account. So that's actually the regular payments that she's making. She's making regular payments of $200. And so all of these 200s come from her regular payments that she's making. Okay? The sum, well, if you actually add up all these numbers together, what you're actually figuring out is the accumulated amount of her investment, or the future value of her investment. So it tells you what the total amount of her investment will be in the future. Okay, so we can use the formula for the sum of the terms in a geometric series to actually derive an equation to determine the future value of an annuity. So we're actually going to use this formula, so the sum of the terms in a geometric series, to actually figure out what the future value of an annuity formula is going to look like.